Hi, this is Stu Schwartz from MasterMathMentor.com. This is Super Free Response Practice AB question number 2. Super free response questions are similar to the typical free response questions in past AP exams. But instead of having the usual 3 or 4 subparts, these will have a great many more. It allows us to use the problem setup as a source of many inquiries that can be taken and allows us to do an in-depth study of the situation. Because of that, many calculus concepts are tested and some reiterated. Doing these will take more than the usual 15 minutes, but by tackling all subparts, you will know what topics you need to emphasize as you prepare for the AP exam. It is recommended that you go to the MasterMathMentor website and download the PDF with the actual problem and subparts. If you don't have a printer available, use a piece of paper for parts A, B, C, etc. This video will just show you the solutions, although you can fast forward at times to bypass the solutions and just show the problems. Question 2 reads, the velocity of a freight elevator at a high-rise building construction site is given by the differentiable function v sub f, where v sub f is measured in feet per second and t is measured in seconds. Selected values of v sub f are shown in the table below. There are 10 feet to a floor, with the ground floor being floor 0, and the freight elevator is on the 30th floor at time t equals 0. We see in the table that we have various times and corresponding v sub f's in feet per second. Our times are 0, 10, 20, 25, 30, 45, and 60, and the corresponding v sub f's are 3, 20, 14, 5, negative 6, negative 33, and negative 33. Problem 2 is a particle motion problem. It can be found on the Calculator Active Free Response section, or not, based upon its complexity. While a particle motion problem can give students the position of a particle and ask them to answer questions about the velocity and acceleration, it is more usual to start with the velocity, asking students about the acceleration by differentiating, or ask them about the displacement or distance traveled by integrating. Some problems, like the one shown here, give two particles moving in the same period of time. One as given as a series of times and velocities, and the other by a differentiable function in blue. With the data points, questions of displacement and final position, if the position of the particle at time 0 is given, can be investigated with Riemann sums, or as shown here, a trapezoidal rule. If the numbers are easy enough, calculators will not be necessary. With the differentiable function, questions of how far left or right of its beginning position can be found by integrating using the calculator's FNINT command, and how far it actually travels can be found by integrating the function's absolute value. There is a wealth of questions that can be asked from a particle motion setup, and this particular super free response problem tackles just about all possible questions that can be asked on the exam. Part A asks to determine the minimum number of times that the elevator must be stopped within the 60 seconds, and we need an explanation. The elevator stop means that V must equal 0. In the supplied data, there are no values of t for which v is equal to 0. However, since v is differentiable, it is continuous. So, by the intermediate value theorem, there must be some time between t equals 25 when v is positive and t equals 30 when v is negative, such that v is equal to 0. There may be other times as well, but because only selected values are given, that is the only one that we are sure of. For grading this problem, 1 point is given for the answer of one time. 1 point is given for invoking the concept of differentiability and continuity. And 1 point is given for narrowing down the time interval. The time interval wasn't asked for, but in order to give a full justification, it must be mentioned. Part B asks to justify why there must be at least one time for t between 45 and 60 inclusive, in which the elevator has no acceleration. Since v is differentiable, then by Rolle's theorem, since v of 45 is v of 60, which is negative 33, then there must be at least one time on the interval 45 to 60 where v prime, which is a, has to equal 0. 2 points for this problem. 1 point for stating that v prime is equal to a, and then 1 point for the explanation. The explanation should use Rolle's theorem, or it could also use the mean value theorem. Question C asks, what is an approximation to the instantaneous rate of change of velocity at t equals 20? And we need to indicate units. Instantaneous rate of change of velocity is just talking about the acceleration. And in order to approximate the acceleration with points, we need to take a look at points around t equals 20. So there's 3 possible answers. V of 20 minus v of 10 over 20 minus 10, which is 14 minus 20 over 20 minus 10, which is equal to negative 0.6 feet per second squared. Or v of 25 minus v of 20 over 25 minus 20, which is 5 minus 14 over 25 minus 20, or negative 1.8 feet per second squared. Or v of 25 minus v of 10 over 25 minus 10, which is 5 minus 20 over 25 minus 10, which is negative 1 feet per second squared. Any one of these answers is okay. 2 points for this problem, 1 point for either of the answers, and 1 point for the correct units. D asks, what is the average acceleration of the elevator over 60 seconds? And again, to indicate units. This is really the same question as C. To find the average acceleration, we take a look at v of 60 minus v of 0 over 60 minus 0. And that gives us negative 33 minus 3 over 60, and that is negative 3/5 feet per second squared. Note also that we could think of this in terms of an integral. It would be the average value of the acceleration function. And that would be the integral from 0 to 60 of a of t dt over 60 minus 0. But the integral of a is simply v. So that would be v evaluated from 0 to 60 over 60. And that would give the exact same answer. In terms of grading, again, 2 points. 1 point for the answer and 1 point for the units. E reads, use a midpoint sum with 3 rectangles to approximate the value of 1/10 the interval from 0 to 60 of v sub f of t dt and interpret why this approximation is inaccurate in the context of the problem. There are many ways to set up three rectangles, but only one way to set up three midpoint rectangles, as in any midpoint rectangle, one of the t-values must be the midpoint of the other two. So our three midpoint rectangles will go from 0 to 20, then 20 to 30, then 30 to 60. So 1/10 the integral of 0 to 60 of v sub f of t dt is 1/10 times the quantity 20 times 20 plus 10 times 5 plus 30 times negative 33, which is negative 540 over 10, which is negative 54. And the interpretation, therefore, is that the elevator dropped approximately 54 floors in that minute. This is impossible, as the elevator was originally on the 30th floor, and it cannot drop 54 floors. This shows why the midpoint rectangle method, in this case, is not good. Here is the allocation of points for this problem. 1 point for the calculation of the integral, 1 point for the explanation of what the integral represents, and 1 point for the explanation that it is impossible for the elevator to drop 54 floors. In F, you are asked to use a trapezoid sum with the four intervals 0 to 10, 10 to 20, 20 to 30, and 30 to 60 to approximate what floor the elevator will be on after 60 seconds. We again show our four trapezoids in the graph. And when we calculate 1/10 the integral from 0 to 60 of v sub f of t dt, we use this to be 1/10 times 1/2 the base. And the first trapezoid has a base of 10, so 1/2 of that is 5, times 3 plus 20. The second trapezoid will be 5 times the quantity 20 plus 14. The third trapezoid 5, quantity 14 minus 6. And finally, the last trapezoid will be base of 30, so 1/2 of that is 15 times negative 6 minus 33. And that gives negative 260 over 10, which is negative 26. This means that the elevator dropped approximately 26 floors, and since it started on the 30th floor, it is approximately on the 4th floor. Again, 2 points, 1 point for the trapezoidal area, 1 point for the final answer. In G, we're asked to use the trapezoid sum using all of the data to approximate the average speed of the elevator in floors per second. There is a trap here. Note that the problem asks for the average speed, not the average velocity. Speed is always positive. So in calculating the average speed, we must look at the integral from 0 to 60 of the absolute value of v sub f of t dt all over 60. And when we use our values, we will therefore only use positive values. So using our trapezoids, we get this area is approximately 5 quantity 3 plus 20 plus 5 quantity 20 plus 14 plus 2.5 quantity 14 plus 5 plus 2.5 quantity 5 plus 6 plus 7.5 quantity 6 plus 33 plus 7.5 33 plus 33, and that is all divided by 60. When we do the arithmetic, we get 1,147.5 divided by 60, which is 19.1 feet per second. So in terms of floors, we divide by 10, and we get that the average speed is 1.91 floors per second. 3 points for this problem, 1 point for generating the trapezoidal area, 1 point for dividing by 60, and then 1 point dividing by 10 to get the final answer. There is a maximum of 1 point on this problem if negative numbers are used in the trapezoidal calculation. H reads, a second elevator that is meant to take only workers and not equipment to different floors has velocity for t between 0 and 60 inclusive as v sub w equals 101 sine of t divided by 4.8 all over 0.05 t plus 2 measured in feet per second. And we want to determine the percentage of time that the speed of the elevator is greater than 28 feet per second. This is a graphing problem. We graph the function in blue, and we also graph y is equal to 28 and y is equal to negative 28 because we are talking about speed. So we are interested in where the v function is greater than 28, and we see that that is between 3.071 and 11.284. We also find the interval where our v is less than negative 28, and we get t must be between 19.766 and 24.803. So to find the percentage of time, we look at the time intervals and we calculate 11.284 minus 3.071 plus 24.803 minus 19.766 and divide it all by 60. We get 13.250 divided by 60, which is 22.1% of the time the speed of the elevator is greater than 28 feet per second. For grading, we get 1 point for the interval of time when v is greater than 28, 1 point for the interval where v is less than negative 28, and then 1 point for the final answer in terms of percentage. Question I asks, how far does the worker elevator travel when its speed is greater than 28 feet per second? And we want to show how you got your answer. This problem goes hand in hand with question H. In that problem, we determined the values of t for when the worker elevator had a speed greater than 28 feet per second. Now we would like to determine how far the elevator travels when that speed is greater than 28 feet per second. And that is simply the areas under the curve shown in green. We have established the points of intersection on the previous problem, so we just need to set up two intervals. The first interval is the interval from 3.071 to 11.284 of v sub w dt. And the second interval, since the v is negative, we will subtract the integral from 19.761 to 24.803 of v sub w dt, and we get 309.507 plus 155.730 to get a total of 465.237 feet. For grading, 1 point is allocated for the first integral, 1 point for the second integral, and then 1 point for the final answer in feet. Question J asks, in the 60 seconds, determine how many times the worker elevator is speeding up, and the answer must be explained. To do this, we are going to handle it graphically by looking at the v function and also the a function. And the a function is the derivative of the v function. There are two ways of doing this. One is to use the quotient rule. And when we use the quotient rule, we square the bottom, and the numerator will be the bottom times the derivative of the top, which is 0.05x plus 2 times 101 cosine of x divided by 4.8. And we must divide that by 4.8. And now the second part of the numerator will be minus the numerator, 101 sine of x over 4.8, times the derivative of the denominator, which is 0.05. Or, much easier, we can say y2 is equal to n deriv of y1 comma x comma x. This is permissible on the calculator section. Speeding up means that both the velocity and acceleration have the same sign, either both positive or both negative. And we can see by the green lines that this occurs in 4 distinct sections on the graph. For grading, 1 point is given for the answer and then 1 point for the explanation. Question K asks, if the worker elevator started on the 5th floor, what floor is it closest to after 60 seconds? We are interested in the displacement of the elevator. We show the graph, and the section above the x-axis is when the elevator is going up. Below the x-axis is when the elevator is going down. And therefore we have positive area and negative area. And that is simply the integral from 0 to 60 of the v function, 101 sine of t over 4.8 over 0.05t plus 2 dt. However, we must add 50 onto our value because we're interested in where the elevator ends up, and it started on the 5th floor. So we get 50 plus 140 plus 0.302, which is 190.302. And we're interested in the floor, so we take that and divide that by 10, and our answer is approximately 19. For grading, 1 point is given for the integral, 1 point for adding 50, and then 1 point for the correct floor, 19. Question L asks, what is the average speed of the worker elevator in floors per second? This problem also involves an integral. However, we must integrate the absolute value of v because we're interested in speed. And there are no negative values when we're interested in speed. So the average speed will be the integral from 0 to 60 of the absolute value of our v function, 101 sine of t divided by 4.8 all over 0.05t plus 2 dt, and then we divide our result by 60. This gives an average speed of 1,179.498 divided by 60, or 19.658 feet per second, which translates to 1.966 floors per second. When doing this calculation, be patient. Depending upon the age of your calculator, it could take up to 30 seconds to do this calculation because of the absolute value. For grading, 1 point is given for the limits of the integral, 0 to 60, and the constant, division by 60. 1 point for integrating the absolute value of v sub w, and then 1 point for the answer. Part M reads, approximate the highest floor that the worker elevator reached and justify the answer. To determine the largest value of h, we need to determine where v switches from positive to negative. And we can see by the graph that the maximum value of h must occur at t equals 15.079 or t equals 45.239 as found on the calculator, as our v sub w switches from positive to negative at those values. We then calculate h of 15.079 and h of 45.239. Note that it really is not necessary to do the 45.239, as we can see by the areas that there is more area from 15.079 to approximately 30 below the axis, or as there is from 30 to 45.239 above the axis. So that indicates that the maximum value of h will occur at 15.079. The value of that is 50 plus the integral from 0 to 15.079 of sine of t over 4.8, all divided by 0.05t plus 2, and we get 459.874 feet. We can also do the same thing for 45.239, and we get 399.364 feet. So therefore, the maximum height of our worker elevator is 459.874 feet, and we divide that by 10 and realize that it gets just about to the 46th floor. This is a 4-point problem. We need 1 point for the explanation, 1 point for the possible values of t, and if it is shown that the larger value of t is impossible because of area, as mentioned in the solution, then credit is given. 1 point for finding h of 15.079, and then 1 point for the final answer in terms of the floor. Question N reads, the height of the freight elevator is modeled by h sub f is equal to t to the fourth over 2,000 minus 19 300ths t cubed plus 37 20ths t squared plus 300, where t is a number between 0 and 45 with t measured in seconds. And we want to know on what floor does it first stop when the elevator starts to move. The original problem gave selected values of t and corresponding values of the velocity of the freight elevator. This problem now gives you the height of the freight elevator in terms of t. Note though that it only goes from t between 0 and 45. In order to do this, we first of all will take v of the freight elevator, which is the derivative, and we get t cubed over 500 minus 19 100ths t squared plus 37 tenths t, and we set that equal to 0, and we get t is equal to 27.344. We now plug our 27.344 back into our h formula and get 667.911. And that means that the floor is 667.911 divided by 10th, and the elevator first stops on approximately the 67th floor. 3 points for this problem, 1 for determining v, 1 for determining the value of t, and then 1 point for the final answer. Question O reads, what is the lowest floor that the freight elevator reached for t between 0 and 45? Explain. We use the same picture of v sub f as we used in the previous problem. We see that v sub f is first positive and then negative, so therefore the minimum value must occur at one of the endpoints. H of 0 is 300 and h of 45 is 325.313. So the lowest floor that the elevator reaches is where it started, on the 30th floor. For this problem, you must test both endpoints to get 1 point, and then 1 point for the conclusion. Question P reads, Once both elevators started to move, at how many times did they have the same velocity? This is a calculator problem. We graph V sub W in blue from 0 to 60, which was given, and our V sub F from 0 to 45 in red, which we found on a previous problem. We find that the graphs of the two velocities intersect at two locations beyond t is equal to 0. There is only 1 point given for this problem for the correct answer of 2. Question Q reads, once both elevators start to move, at how many times did they have the same speed? This is not the same question as P, as we are interested in the same speed rather than the same velocity. So we will now graph the absolute value of our velocities. The absolute value of V sub F in red and the absolute value of V sub W in blue. And we find that the graphs of V sub F and V sub W beyond t equals 0 intersect 5 times. So again, only 1 point for the answer of 5. Question R asks, to determine whether the two elevators are within one floor of each other at t equals 43. And we want to show how you arrive at your conclusion. We find the heights of the two elevators in different ways. We have a statement for height for the freight elevator. So HF of 43 is simply 43 to the fourth over 2,000 minus 19 over 300 times 43 to the third plus 37 over 20 times 43 squared plus 300, and we get 394.607. To find the height of the worker elevator, we find HW of 43, which will be 50 plus the integral from 0 to 43 of sine of t divided by 4.8 over 0.05t plus 2 dt. And we get 386.996. Subtracting the two values, we get approximately 7.761. And that means that the elevators are within about 8 feet of each other, meaning that they are within one floor. 3 points for this problem, 1 for finding H sub F of 43, 1 for finding H sub W of 43, and 1 point for the conclusion. Question S reads, referring back to question R, are the two elevators getting closer together at t equals 43? And we need an explanation. The answer to this is yes. We have seen in part R that at t equals 43, the freight elevator is above the worker elevator. And the velocity of the freight elevator at t equals 43 is less than 0, as shown by the graph in red. So the freight elevator is going down. But the worker elevator VW of 43 is greater than 0, as shown by the graph in blue. So the worker elevator is going up, and therefore the two elevators are getting closer together. A good question is whether the two elevators actually get to the exact same height. You need to do this by trial and error, looking at values around t is equal to 43. For this problem, there are 2 points, one for the conclusion that the elevators are getting closer together and 1 point for the explanation. If there is no explanation, then no points are awarded. Question T, the last question, asks, when the building is completed, the construction elevators are removed and passenger elevators are installed. Below is a 60-second graph of the velocity v sub p of the elevator. Briefly explain the difference in the type of ride experienced in the freight elevator and the type of ride experienced in the passenger elevator. This is a different type of question because no calculations are required. However, we need to examine what is going on with the two speeds. We look at the passenger elevator in purple and we see that once it gets up to speed, it travels between floors at a constant rate. So it only accelerates when getting up to speed and decelerates when slowing down to stop. The freight elevator accelerates until it reaches a top speed and then decelerates until it stops. It also, when goes down, it does the same exact thing. It is clear that the passenger elevator is slower because its velocity is smaller in general than the freight elevator, but it is a much smoother ride. 3 points for this problem. 1 point for slower, 1 point for smoother, and 1 point for the explanation. There are 50 points available for this question. There is no exact formula for what number of points will constitute a 5, 4, 3, 2, or 1 on the AP exam. However, these percentages are what have been used in the past based upon exams released by the College Board. While you can extrapolate for just this question, realize that this question only tests a limited number of AP topics. So it is recommended that you do a number of the super free response questions in this series. Then combine your results, total your points, and then use these percentages to get a feel for how you will do in the AP exam. And more importantly, what concepts you need to strengthen in order to improve your score.